We'll begin today exactly where we left off yesterday, picking up with the section on rhombuses, or rhombi. So you can go ahead and open up that section. And we're looking at the example problems here. So first, if the measure of angle RST, so this angle right here is 67 degrees, find the measure of angle RSW. So remember, this whole angle, we're looking for this angle right here. So the diagonals on a rhombus bisect opposite angles, which means that it cuts this angle exactly in half. So this angle should be exactly half of the total angle. So 67 divided by 2 would be 33.5. Example 2, find the measure of angle SVT, if the measure of angle STV is 135 degrees. So again, this angle right here is going to be exactly half of the total, and these two angles added up are going to equal 180 because they're supplementary. So I know that 180 minus 135 is my total angle here, and that would be 45 degrees. And then half of that 45 is going to be the angle that I want. So 45 divided by 2, which is 22.5 degrees. If the measure of angle SWT, so this central angle, equals 2x plus 8, find x. Remember that the diagonals are perpendicular to each other, which means that this is a right angle. So that means 2x plus 8 equals 90 degrees. Subtract 8 from both sides. 2x equals 82. And then divide by 2. And that's going to mean x equals 41. Next, find the value of x if the measure of angle WRV equals 5x plus 5. WRV is this angle right here. And the measure of angle WRS equals 7x minus 19. Remember, this diagonal bisects this angle, cuts it exactly in half, so these two halves are going to be equal to each other. So 5x plus 5 is going to be equal to 7x minus 19. So I'm going to subtract 5x from both sides of this equation, and also add 19 to both sides of the equation. So this cancels out on this side, and this cancels out on that side. 5 plus 19 is 24, and 7x minus 5x is 2x, so divide by 2, and we get x equals 12. Okay, now let's move on to squares. A square is a rectangle and a rhombus. So it counts as both a rectangle and as a rhombus. In a square, opposite sides are parallel to each other. So those two sides are parallel, and these two sides are parallel. Opposite sides are also congruent in a square because all four sides are congruent. In a square, all four sides are, of course, the same size. And opposite angles in a square are also congruent because in a square, all four angles are right angles, so they're all the same. Consecutive angles are supplementary in a square, meaning that they add up to 180, which of course, because 90 plus 90 is going to be 180. And any two angles next to each other are going to be that way. The diagonals bisect each other in a square. So these diagonals cut the angle exactly in half, and so into 45-degree angles. As we mentioned, it has four right angles. Also, the diagonals are perpendicular to each other. So right angles all around. And it has four congruent sides, as I mentioned earlier. The diagonals are congruent to each other, meaning that this line and this line are equal to each other. And the diagonals bisect the opposite angles. Oh, so I mentioned that earlier. Actually, with this, it should have been that they bisect each other, which means that they divide into equal halves. Okay, let's move down to the examples. Example 1, if the measure of angle AED equals 5x plus 5, find x. This, of course, is perpendicular, so that means it's a 90-degree angle. So 5x plus 5 would equal 90, minus 5 on both sides would get you 85, and then divide both sides by 5. 85 divided by 5 is 17. The angle of BAC, so this angle right here, equals 5x. Remember that this is going to be half of the 90, so it's going to equal 45. So I just have to divide both sides by 5, and that'll get me that x equals 9 in this case. If MH equals 8, find the length of AH. So for this, we're going to use the Pythagorean theorem because this forms a right triangle within the square. So this is 8, this is also 8 because it's a square, and then we just got to figure out what this third side is. So 8 squared plus 8 squared would equal AH squared. 8 squared is 64, so 64 plus 64, which is 128. So we would want the square root of 128. And that's going to simplify to 8 square root 2. If MS equals 3 and AS equals 3, find the perimeter of the square. So this also is a right triangle, and I know that this is 3 and this is 3. So again, I'm going to do 3 squared plus 3 squared to get AM squared. 3 squared plus 3 squared equals the length of AM squared. 3 squared is 9, so 9 plus 9 equals 18. And then the square root of 18, which would be 3 square root 2. So each side of the square is 3 square root 2. So this times 4, 3 times 4 is 12. So it would be 12 square root 2 for the perimeter of the entire square. Okay, moving on to trapezoids. Trapezoids have exactly one pair of parallel sides. The median of the trapezoid, this right here, is equal to 1/2 times base 1 plus base 2. So this is one base of the trapezoid, base 1 usually. This is the other base of the trapezoid, base 2 usually. This right here is the median of the trapezoid, and then these are considered the legs on the sides. And the sides, or the bases, are parallel to each other, and the median will also be parallel to both sides if you drew a median across the middle. Now, an isosceles trapezoid is a special kind of trapezoid that still has exactly one pair of parallel sides, but it has other things about it as well. The median still equals 1/2 base 1 plus base 2, but for a isosceles trapezoid, the legs are congruent. So these are both parallel, and then these legs would be congruent to each other. The diagonals of a isosceles trapezoid are also congruent. So these two lengths would be congruent to each other. And then finally, the base angles are also congruent on an isosceles trapezoid, meaning this angle and this angle are congruent to each other. So finding the value of x, because we know these sides are parallel, this would be like a transversal, and these would be like same side interior angles. Remember, same side interior angles add up to 180 degrees. So 12x plus 3 plus 13x plus 2 equals 180. 12x plus 13x is 25x. 3 plus 2 is 5. And then we would subtract 5 from both sides. 25x equals 175. Divide both sides by 25. And we get x equals 7. Number 2, we have AB equals 7y plus 6. And EF equals 5y minus 3. And DC equals y minus 2. Now I know that the median, which is this middle one, equals 1/2 times base 1 plus base 2. So I can just set all this up. 5y minus 3, which is the median, equals 1/2 of the sum of the other two, y minus 2 plus 7y plus 6. Y plus 7y is 8y. Negative 2 plus 6 is 4. So half of that. 5y minus 3 equals half of 8 is 4. Half of 4 is 2. Then I subtract 2 from both sides. Then I add 3 to both sides and subtract 4y from both sides. So cancel and cancel. 5y minus 4y is just 1y, and 2 plus 3 is 5. So y would equal 5. DONE is an isosceles trapezoid. The measure of angle EDO, so this angle right here, is 110 degrees, and the measure of DEN, so this angle right here, is 15x minus 5 degrees. Again, because these are parallel lines, these would be like same side interior, so they would be supplementary. So 15x minus 5 plus 110 would equal 180. Negative 5 and 110 would be 105, so I'm going to subtract 105 from both sides. So 15x would equal 75, divide by 15. X equals 75 divided by 15, which is 5. TRAP is an isosceles trapezoid. If PR equals 3x minus 7 and TA equals 20, find the value of x. Again, the diagonals here are congruent for an isosceles trapezoid, so I know that 3x minus 7 is equal to 20. Then I can just add 7 to both sides. 3x equals 27. Divide both sides by 3. X would equal 9. Okay, one final segment. I don't have a window for this, so this is going to just go on a page in your notebook and go on the next page over from where you have glued your book of quadrilaterals. We need to do a quick section on kites. So this is kites. So first we'll draw a kite. So important facts about kites. First, it has 2 pairs of congruent sides. So these 2 sides are congruent to each other, and these 2 sides are congruent to each other in a kite. 1 pair of diagonally opposite angles is equal. So this angle is congruent to this angle. Only one diagonal is bisected by the other. So here are the diagonals that go from opposite corner to opposite corner, but only this one is cut in half. This one is longer on this side than it is on that side. But finally, the diagonals do cross at 90-degree angles, so they are perpendicular. So these cross at right angles. And that's it for kites. So this is all that you need to know about quadrilaterals to do your Alex's and also to complete your Get to Know a Quadrilateral project.